This video is going to go over how to complete the review for Part B of our statistics unit. So to get started, we're going to talk about Learning Target 6, which is how to calculate and interpret a weighted average. So Kevin's grade in a history class consists of 50 tests, 50%, quizzes, 10%, a paper, 10%, and a final project, 30%. His scores for each of the categories are as follows. He earned 75% on tests, 90% on quizzes, 92% on papers, and 74% on the final project. Asked me to calculate his overall grade. So, in order to calculate his grade, we first need to determine how much of Kevin's grade is going to come from his tests. So 50% of his grade comes from his tests, that's his weight. Now how much of that does he actually earn? He earns 75%, so I'm going to multiply 50 by 0.75. I'm going to multiply my weight of 10% on quizzes by the percent he got on quizzes. I am going to multiply the weight he gets on papers by the percentage he earns on papers, and added to final project is worth 30% of his grade, and the final weight is 0.7. He earns 74%. So this is how much he earns based on his tests. So 50 times 0.75, 37.5% of his final grade is being contributed by tests. 10 times 0.9 is 9. 10 times 9.2 is going to be 9 times 9.2. 10 times 0.92 is 9.2. And 30 times 70.74, 22.2. To calculate his final grade, I need to total these up. So 22.2 plus 9.2 plus 9 plus 37.5 gives a grand total of 77.9% as his final grade. Alright, now almost in reverse. In an English course, a student's grade is composed of 50% on papers, 25% on the quizzes they take, and 25% for a final exam. That student earned 85% on all the papers and 80% on their quizzes. What is the minimum score that a student needs to earn on the final exam to achieve an overall grade of B, or 84? So, I don't know what the last category is going to give me, but I do know the first two. So, for weight of 50, if I earn 85% of that 50, I'm going to multiply those. Out of the 25% I get for quizzes, I earn 80%. Plus, now the last category is also worth 25%, and it's being multiplied by some percentage. Equals, what's my goal? 84. So notice on this problem, I knew them all, so I could just add them all up to get my total. On this one, I know what my total is supposed to be, but I'm missing one component. But remember, to get that component, I have to times the weight by the percent. So I'm going to work backwards. This is an equation. I need to solve for x. So all of these things are being added, so I'm going to subtract them. But let's multiply so we know what to subtract. 50 times 0.85 is 42.5. 80 of 25 is 20. Plus 25x equals 84. So I'm going to subtract 84, subtract 20%, the 20% that I get from quizzes, and 42.5 that I earn from tests. So I get 25x equals 21.5. Now please do not stop here. Remember, that's just how much I need to get for my test, for my final exam. Remember, I could have a percentage of 25, but I only need to get 21 of those, 21.5 of those percentage points. So to find my final percent, I'm going to divide by the total. Okay, this is my part over my whole. So 0.86 as a percent is 86%. All right, question number 3. Draw a best line and then estimate the equation. So these are going to vary. It's going to depend on what your line looks like. But let's say my line comes through here. I think that looks like a pretty good line of best fit. It goes through most of my points. I'm going to write the equation by first finding 2 points. This crosses at my y-intercept. So I'm going to make sure I write that one down, and I'm going to pick one other point. Now as I look along my line, I don't need to put it where the x's are. I just need to find an ordered pair that crosses out a whole number so I don't have to estimate. So 12, 18. And if there's one along here that you thought was better, I can use that as well. So to find my best fit line, I need my slope. So I'm going to calculate my slope by subtracting 18 minus 30 and 12 minus 0. 18 minus 30 is negative 12 over 12. That simplifies to negative 1. So far I have y equals negative 1 x plus, and my y-intercept is right here at 30, so plus 30. Now your slope might be a little bit different, but if you divide and look at the decimal, it should be near negative 1. It might be negative 0.8. You can even look at my answer key. I believe it's like negative 0.83. So my best line was different, fit line was different, so my equation was different. Just make sure that matches. If I'm drawing for number 4, that looks kind of where it starts, and there's my general trend. So to write my line of best fit, I'm going to write 2 ordered pairs. It crosses right here through 0, 5, and it also looks like it crosses right here through the point 8, 10. So to find the slope, 10 minus 5 and 8 minus 0. So positive 5 over 8. I'm going to change that to a decimal so that we can compare. 5 divided by 8 is 0.625. So I have y equals 0.625x, and my y-intercept is 5. Again, your slope might be different depending on your line. Just show me how you got your slope. Alright. Using the scatter plot below, it shows time spent studying and a midterm score y for 25 students. So I've got 25 dots. This is the best fit line, and I'm going to use it to answer my questions below. For 2 hours spent studying, what is the midterm score? So for 2 hours studying, remember hour studying is my x variable. Now I want an exact answer. I don't want to just kind of guess where it is. So I'm going to use my equation, and I'm going to plug that time spent studying into x. So into my calculator, I'm going to type 3.78 times 2 hours plus 15.55, 0.88, pardon me, oops, sorry, 7.56 plus 15.88 is 23.44. Points. We'll label it. If someone scored 53.6, how many hours? So if I look at my graph, this is my score. The midterm score is the y variable. So instead of plugging into x, I'm going to plug into y. So 53.68 equals 3.78x plus 15.88. In order to solve, I'm going to subtract my 15.88. So 53.68 minus 15.88. So 37.8. Let's rewrite our equation. Equals 3.78x, and when I divide 0.78, I get a grand total of 10 hours. And that is how I'm going to use my best line of fit to make predictions. Let's go ahead and flip this over. Okay, it says use the equation. Notice this equation matches exactly the previous graph. It says graph above. It's just talking about the graph on our previous page. Remember that the x is the time spent studying, and the y is my midterm score. So interpreting the slope. Well, here's my slope. 3.78 is my slope, but it says interpret. So I'm going to write a sentence. The very first thing I'm going to do is make it into a fraction. Remember that when I calculate a slope, that it's the y, change in y over the change in x. If I go back to my old graph, y stood for midterm scores, and x stood for time studying. So midterm score, time studying. And this is how much it's changing. So when I interpret the slope, what I'm going to do is I'm going to talk about how much this y variable and x variable are changing. So I'm going to say for each additional 1 hour of studying. Now where did I get that from? Why did I say that? 1 is in my denominator, and 1 stands for time studying. So for each additional 1 hour of studying, so as I'm changing my hour of studying by 1, okay, the midterm score, now I'm going to talk about my y variable. My midterm score, is this positive or negative? Positive, so I'm going to say increases by 3.78, and I'm done. So I'm saying as I increase my hour of studying by 1, I increase my midterm score by 3.78. Interpreting the y-intercept. Remember that the y-intercept, the x value is 0, and the y value is whatever my y-intercept is. So there is my ordered pair. 15, I ran out of room in those parentheses. So 0, 15.88. Now how do I interpret that? Well, remember, x stands for the time spent studying, and y stands for the midterm score. So I can say for no time studying, or I could say for 0 hour studying, that's the same as no time studying. Okay, the person will score 15.88 on their midterm. And that is how I interpret. Let's go ahead and talk about question 9. So it says, we're trying to distinguish between correlation and causation. So I have two scenarios. Here's scenario 1, or A. Maria compared players' statistics from her team's tennis season and determined that being taller implies that the player has a faster serve. So taller means if height is increasing, the serves are increasing. So that's for scenario A. Scenario B, a phone company determined that an increase in income does not indicate a change. I don't know. Question mark. There's no pattern for their customers' phone usage. Question A asks, which scenario found no correlation? Well, remember that a correlation is a relationship that I notice. I notice a relationship on scenario A, so I can't say A, but there's no relationship. Okay, there's no change in specific direction, so I'm going to say scenario A. Which scenario found a correlation? Well, that would be, scenario B. I miswrote that. Which one did find a correlation? Scenario A did, because there was a pattern. Scenario A. And is this correlation positive or negative? It is positive because both are increasing. Remember that negative is when one is increasing and one is decreasing. And part C, do any of these scenarios have causation? So if you'll remember our video about summertime and sharks, remember that just because there's a relationship, just because I'm noticing something doesn't mean that there's a causation. For example, an increase in ice cream sales and an increase in shark attacks, I can see that there's probably a pattern trending. They both may be going up because of the summertime temperatures, but one does not cause the other. So if I'm looking for any scenario that has a causation, first off I need to see if it has a correlation. Which one has a correlation? A does. So it's possible A has causation, but I'm going to dive deeper. So I'm going to ask myself, does being taller make you serve faster? Okay. Does one cause the other to happen? Okay. Well, does one cause the other to happen? And I'm going to say there's no causation for scenario A, because I can think of another reason somebody would serve faster. Maybe that they're practicing more. Maybe faster serves come from muscle strength, and muscle strength causes people to be taller and serve faster. Okay, but being taller does not make you serve faster, because I think a lot of you can think of some pretty short players that might have a fast serve. So no causation for scenario A or B, because it doesn't even have a correlation. All right, let's finish up the last two sections. So I am asked on question number 10, which has the strongest positive correlation. Now if I look at each of these scenarios, there's no pattern here, so nothing is strong. There's no strong correlation here. Figure 2 is a strong correlation, but it is a negative correlation. Same with this one. Now this is a positive correlation, and it's the strongest positive correlation that I see. So I'm going to answer figure 4. Okay, part B. Which correlation has a coefficient closest to 0? So what is that asking? That's asking which has the smallest correlation. Okay, closest to 0 means there's not much correlation, or there's not much pattern to be seen. And I can see that figure 1 is way spread out, so figure 1. Now figure 2, part C says figure 2 has a correlation of negative 0.99. They told me not only is it negative, but it's 0.99. Figure 1 has a correlation of negative 0.81. And you might have said, I had no clue it was even negative. There wasn't a pattern. Okay, well, it's so slight that you can't tell. And it's so slight, it's 0.18. So it is really close to 0. We can't tell, but it is negative. And the question says to estimate the correlation coefficient of figure 3. So we already guessed that this was negative because it was going down. And remember, correlation coefficients are how close these dots are to my best fit line. Now on figure 2, they're almost right on. There's just maybe 1 or 2 that's off. So the further my dot's away, the smaller, I should say, the closer this number gets to 0. But notice 0.18 is really spread out. So I don't want to have this go down that much. I'm going to just estimate a little smaller than 0.99, and I'm going to guess 0.85. Now, if you were to guess negative 0.8 or negative -0.9 or -0.75, I would say that those are all good estimations because it's a strong correlation. It's pretty close to -1, but it's not exactly because the dots are a little bit further from that line than this one right here. So -0.85. All right. Section 12. It says I want to be able to know what a residual is and know what it is in context of my best fit line. So I've got this scatter plot that shows the number of years of experience and then the hourly pay rate. So this is what I'm actually observing. I collected data. I plotted my data on the graph. Those are all the little X's, and then I drew in this best fit line. And I found that the best fit line, and that is a typo, that should say 0.9, should be fixed on your end. Best fit line is this formula right here. Now, how do you calculate a residual? Well, first off, what is it? So a residual is the distance, remember that is the distance from the line. So how do I calculate that distance from the line? Well, first off, I need to know where the dot is. So, for example, what is the residual for 2 years of experience? So I go to my table. 2 years of experience is my hourly pay rate is about 9.09. We call this as what is observed for 2 hours, for 2 years. Notice that that corresponds to this dot on my graph. I'm trying to figure out how far away it is from this line. It's pretty darn close. It's less than 1 space away. But how far is it exactly? So I'm going to find, well, how high is that actual dot? Well, it looks like it's around 10, almost, but I want to find it exactly. So how do I find where it is exactly? Well, my best fit line will tell me where it is exactly. So I'm going to, in my calculator, take 0.9, because that's my equation, so 0.9 times 2 years of experience plus 7.88, 9.68. So my best fit line is at 9.68. So how far off was my observation? How far off was the X? So in my calculator, I'm going to take 9.09 minus 9.68, and I get negative 0.59. And yes, the sign does matter. This negative tells me that my dot is below my predicted line. So make sure you take observed and minus the predicted. So let's try that again. So for 5.1 years of experience, that corresponds to 14.5 observed hourly pay rate. And I'm going to minus my predicted. So if you'll notice 5.1, that's this dot right here. It's further away. So my number should be bigger. Let's calculate. 0.9 times 5.1 years of experience plus 7.88 is a grand total of 12.47. Now I'm going to subtract my observed minus my predicted. I get 2.03. And I can see that this prediction is further away from the line than this prediction, and it's above. That is all. If you have any questions, please feel free to reach out, and good luck.